Hey everybody, like my glasses? Pretty cool, you must say. Well, these are not regular glasses and they're not 3D glasses. They're what we call diffraction grating glasses. It's a piece of plastic on which are many very closely aligned lines. If you think about turning over a CD or a DVD, and you know how you can see like a rainbow reflected in that? Similarly, through these, I look through and wow, all the lights look like little rainbows. I tried putting it on the camera on my laptop and it doesn't quite work so well. But again, you can mimic this yourself by looking at a DVD or a CD. Now remember, way back in the earlier part of the course, we were talking about how light can be broken up into these different wavelengths, and we could use that to figure out what something was made of. Remember, we call that spectroscopy. Well, here, now in Chapter 9, we're going to apply those techniques to stars, because we're going to now see how the sun rates compared to the other stars in the night sky. We're going to be looking at properties such as mass and such as luminosity or true brightness. We're also going to be thinking about how the mass of a star might affect its evolution. A lot more on that later, but we're going to start thinking about that this week. You're also going to learn about the fact that stars are often born in pairs that orbit around each other, something called a binary star system, sort of like Tatooine from Star Wars or Gallifrey from Doctor Who. So even though science fiction writers have thought about binary star systems and the possibility of life for many years, is it really possible that you could have a planet around a binary star? Well, the answer is yes, we've actually discovered those, but we'll be talking about exoplanets again later in the course. So as you go through this week, really pay attention to how much stars can differ from each other and how their mass is really important to determining these different properties. Now, the way that scientists are going to group stars together that have like properties is by something called a spectral class. They're going to use spectroscopy. And there's a really subtle point here that I want you to pay close attention to. All of the stars are pretty much made out of the same thing, pretty much made out of mostly hydrogen with some helium. But yet, if you look at the spectra of different stars, you will see different spectral lines, say of calcium or magnesium, or even a molecule, titanium oxide. And some stars will have more calcium in their spectra, and some stars will have more titanium oxide in their spectra. So why do stars have what appears to be different chemistries according to their spectral lines if they're all pretty much made out of the same thing? The answer is going to be temperature. It's very important. If you remember back when we were talking about spectroscopy, back in week 3, remember the electrons are jumping up and down between those energy levels. In order for you to see a spectral line, the line has to concur with just the right amount of energy to make that jump. If a star is too hot, it's going to overshoot it, and you won't see that spectral line. And if the star is too cool, it can't make the jump, and you will also not see the spectral line. So depending on the temperature of the star, the electrons in different elements will be able to successfully make those jumps, and you'll be able to see those spectral lines. So read all about that in the book. And again, if you have any questions, don't be afraid to ask.